Page 14, number 65. Solve for x. Now take a look at this triangle, and we notice that two angles, x and z, are congruent, but the 15 and the 4x plus 3 aren't for the angles. So what you should know is that if you have two angles congruent, that means that the side lengths across from them, so 4x plus 3 is across from angle x, 15 is across from angle z, so the sides across from them are going to be congruent as well. So I'm going to put two tick marks here, and I want you to know that this is something called the base angles theorem. By noticing that two angles are congruent in a triangle, you should note that the two sides across from them are always going to be congruent as well. That it's an isosceles triangle. Isosceles. Isosceles. So it's an isosceles triangle. Let's go ahead and let's set these two side lengths equal to each other and solve for x. So 4x plus 3 equals 15. Subtract 3. 4x equals 12. Divide by 4. X is 3. Quick and easy. Let's move on to number 66. Number 66. Now this is a weird looking diagram. What we have is an angle. So here's our angle. And there's a ray that's coming off of that angle. Now that ray shows that it cut our angle into two equal parts because we notice there's an arc here and an arc here. So this ray is an angle bisector. Now the angle bisector theorem tells us that any point along this ray is going to be equidistant to the two sides that make up your main angle. So in this case, we show two distances here. We show the 2x plus 27 distance, and I'm using the word distance because distance is always perpendicular if you're going from a point to a line segment. So from point to this bottom side, I notice that there's a right angle here. So the distance is 12x plus 27. Now the distance to the other side of the angle is 5x plus 9. Those two distances, according to the angle bisector theorem, are going to be congruent. So any point along this ray, it could have been here, it could have been here, literally anywhere along this ray is going to be equidistant to both sides of the angle. So I'm going to put a tick mark here and a tick mark on the other distance to show they're equal. And now I'm going to go ahead and set them equal to each other. So 15x plus 9 equals 12x plus 27. I always start with the x's, so I'm going to subtract 12x from both sides. And I get 3x plus 9 equals 27. Subtract 9 from both sides. And we have 3x equals 18. Divide both sides by 3, and x will equal 6. So x is 6. A good check is to plug 6 back in and make sure that both of the lengths are the same. So this was the angle bisector theorem application. Okay, let's move on. Number 67. Find the coordinates of the centroid for triangle ABC if A, B, and C are the coordinates listed. Leave your answer as an improper fraction. Okay, so we're looking for coordinates of a centroid. Now, this vocabulary word is the point of concurrency for your medians. So as a quick little visual, if this is my triangle, a median goes from one vertex to the midpoint of the opposite side. Then you have another median, so I'll start from the right. right vertex to the midpoint of the opposite side. And wherever they cross, that's your centroid. So we can do this visually and try to approximate the centroid, or we can use a centroid formula. Now, I'm going to go ahead and approximate where the centroid is first, and then I'll show you the formula. So what we're going to have to do first is plot all 3 points and connect this triangle. So my first point for A is at 4, 5. My next point is at 8, 1. And then my last point is at 2, negative 3. I'm going to go ahead and connect. I'm going to do that one again. Okay, so I've gone ahead and I've plotted my 3 points. Let me go back and label them. So this first one was A, second one was B, the last one was C. Now, if I were to approximate where this where the centroid is, I have to draw in the medians. So let me start at point C, and the midpoint looks like it's right about here. I could go ahead and find the midpoint by doing the midpoint formula, but I'm going to approximate. Oh, let me draw that line segment again. Okay, so that's my first median. My second median, let me go ahead and draw from B to the midpoint of the opposite side. It looks like the midpoint is approximately here. It's not a great midpoint because, as we see, my line's pretty shaky. Okay, so I've drawn 2 medians, and I've noticed that the intersection point is right here. Let me try that again. Right here. Okay, that is not a good point. I can't tell what coordinate that is. Now, as long as my answer is somewhere around there, because this is just a rough sketch. Yours is probably better than mine because I'm doing mine on, a computer device. So if this answer is somewhere around there, I'm going to be confident. Now, let me tell you what the actual formula is for finding the centroid. So the centroid formula is going to take all 3 coordinates and average them. So your centroid is going to be x1 plus x2 plus x3, all divided by 3 because there's 3 points. Same thing with the y's. y1 plus y2 plus y3, all divided by 3. Now, let me go ahead and plug in. So C equals x1 is 4, x2 is 8, and then we have 2. So 4 plus 8 plus 2, all over 3. Then we have 5 plus 1 plus a negative 3, all over 3. 4 plus 8 plus 2 is 14. So 14 over 3. Now that's an improper fraction. If we put it into the calculator, 14 divided by 3, it's going to be approximately 4.6 repeating. So it's better if I leave it as an improper fraction for right now. But for the purpose of plotting, we want to see approximately what that coordinate is as a decimal. So I'm going to write down it's 4.6 repeating, 4 2/3. Okay, comma, 5 plus 1 is 6, plus a negative 3. This is a minus. So it's 6 minus 3, which is 3. So 3 divided by 3, we get 1. So 4.6 repeating, comma 1. Let's take a look at our diagram and see if that is approximately what we came up with. So 4.6 is between 4 and 5. So somewhere around here, closer to the 5, and then we have 1 as our y value. So our answer is like right around here. We did a pretty good job of approximating, but now we know the real value. So let's go ahead and write our final answer. Remember, they want it as an improper fraction. So our final answer, 14 over 3, comma 1. And that's the centroid formula. So if you want to go ahead and put this on the back of your reference sheet so that you have it, that would be a great addition. Okay, let's move on. Number 68. Find the altitude of the isosceles triangle below to the nearest hundredth. So find the altitude. This is your ask. If we're looking for altitude, that's a fancy way of saying height. So they're asking you to solve for the height of this isosceles triangle. Now I know it's isosceles because they show me the 2 tick marks, but also they tell me it's isosceles. Now it is very important that they tell you that it's an isosceles triangle, because when you have an altitude drawn in to your isosceles triangle, it's going to split the bottom base into 2 equal parts. So I'm going to go ahead and put 2 tick marks to the left of the altitude, 2 tick marks to the right. So my base of 20 just got split into 10 and 10. And since it's a height and altitude, we want to put in that it's perpendicular to our base. Now that we have that, your goal is try and find h. Now, since we see there are right triangles, you want to focus in, zero in on those right triangles. Because with right triangles, we can use either Pythagorean Theorem or we can use trig in order to solve for a missing length. So I'm going to go ahead and I'm going to take a look at the left side here. This left triangle. I'm going to break it out and redraw it and see what would be the most appropriate approach. So we want h, the bottom is 10, and then the hypotenuse is 16. Okay, so it looks like the best thing to do here is Pythagorean Theorem, because we don't have any angle measures to use trig. So let's go ahead with our Pythagorean Theorem. First thing you want to do is make sure you identify the c. The c is your hypotenuse. It's always across from the right angle. So 16 is our c. 10 and h are either a or b. It doesn't matter. I'll call the 10 a. I'll call the h my b value. So setting the equation up for a squared plus b squared equals c squared. I'm going to do 10 squared plus h squared, the height that I'm looking for, equals 16 squared, the hypotenuse. 10 squared is 100 plus h squared equals 16 squared, 256. Subtract 100 from both sides and we have h squared equals 156. And now to get h, I need a square root. So I get 156 in the calculator. Now I'm going to go ahead and square root it. So the square root of h is 12.4899 and then 6. I'm going to round that last number. The question asked me to round to the nearest hundredth. So that's here. That's where the 8 is. So looking next door, the 9 says to round the 8 up 1. So my final answer is going to be 12.49 units. They didn't tell me inches or centimeters or anything like that, so I'm just going to say units. Okay, so this is another application of isosceles triangle properties. And knowing that when you have the height of an isosceles triangle, it's going to break the base into 2 congruent parts. It's going to bisect it. And then you could use Pythagorean Theorem or you can use trig to solve for whatever's missing. Okay, let's move on. Number 70. Which of the following can form a triangle? So you're looking at which side lengths can form a triangle. Select all that apply. Now the rule for side lengths that can and cannot form a triangle is this. If the two shorter sides added together is larger than your longest side, then yes, they can form a triangle. But if they're equal, then no, it won't form a triangle. And if the two shorter sides are smaller than the longer side, then no, also, it won't form a triangle. So it has to follow this rule. Let's take a look at the first one. The two shorter sides are 3 and 4. Add those together and you get 7. So is 7 larger than the longest side of 7? No, it's not. So it will not form a triangle. The next one, 2, 5, and 8. 2 and 5 are my two shorter sides. Together, again, they make 7. Is 7 larger than 8? And the answer is no. 7 is smaller than 8, so no, these will not form a triangle. Third one, 5 and 6. Those are the two shorter ones. Add them together. We get 11. Is 11 larger than 9? Yes, it is. So the third one will form a triangle. The fourth one, we have 8, 8, and 11. Well, 11 is definitely your longest side, and our two shorter sides are 8 and 8. They're the same. So it's an isosceles triangle if it does form a triangle. 8 and 8 is 16. Is that larger than 11? Yes. So we're going to check off the third option. Our third option is an isosceles triangle. And our last one, 1 and 2. Those are our two shorter sides. That gives us 3. Is 3 larger than 5? No, it is not. So it will not form a triangle. Now, for all of these examples, they listed them in order from smallest to largest. However, you may be given the 3 lengths in any order. Just remember to look for the two shorter sides. Add them together, and if they're longer than your third side, which should be your longest side, then yes, it will form a triangle. So maybe you want to write this down in whatever way it's going to help you memorize it in the back of your reference sheet. All right, so that completes page 70. Yay! Oh, not page 70, page 14, number 70. Okay, let's move on.